While craters on the Moon's surface are formed as a result of meteor impacts, volcanic activity and crustal fractures also play an important role in shaping the surface. In addition, the internal structure and thermal activity of the Moon are among the factors that affect the shapes on the surface. Discoveries on the surface of the Moon have provided important information for humanity. Apollo astronauts who visited the Moon collected lunar soil and rock samples and brought them to Earth. These samples have been used to understand the Moon's geological structure, internal composition, and clues to its history. Additionally, spacecraft and satellites sent to the Moon have also provided detailed maps and images of the surface. There are also future plans to study the Moon's surface in more detail. New space missions to the Moon will be carried out to collect more information and investigate the Moon's geological structure, resource potential and potential bases for future space exploration. The regions called seas on the Moon are actually known as mare, which means sea in Latin. However, these seas are not the same as water seas on Earth. Lunar seas generally refer to large basalt lava plains. Lunar seas are places where the Moon's surface is filled with basaltic lava flows. These lava flows were formed as a result of lava erupted during the Moon's past volcanic activity spreading onto the surface. Seas have a darker color and a smoother surface structure. Now let's examine some of the seas on the Moon. Mare Tranquillitatis is one of the largest seas on the visible surface of the Moon. This is where Neil Armstrong and Buzz Aldrin landed during the Apollo 11 mission. Mare Serenitatis is another large sea located on the visible surface of the Moon. During the Apollo 17 mission, it was visited by Eugene Cernan and Harrison Schmitt. Mare Imbrium is one of the largest seas on the Moon, and contains many craters. This sea is located on the visible side of the Moon. Mare Nectaris is a sea located on the southern surface of the Moon. The craters in this sea are extremely well preserved and clearly visible. Mare Crisium is a sea located on the eastern side of the Moon. This sea is surrounded by mountains around the plains. The Moon is Earth's only natural satellite and has been the focus of great interest as the solar system's closest neighbor. The surface of the Moon has sparked human curiosity and imagination for thousands of years. This mysterious world, which was first set foot on and discovered by humans, has begun to be better understood thanks to geological processes and space research. The surface of the Moon is quite diverse and consists of many regions with different properties. There are various shapes on the surface of the Moon, such as large craters, mountains, plains, volcanic structures and deep valleys. Much of the Moon's surface is covered with craters resulting from meteor impacts. These craters have different diameters and depths. One of the largest craters is the South Pole Aitken Basin, located near the Moon's south pole and is the deepest point on the Moon. There are also many mountains on the surface of the Moon. One of the highest mountains is Mons Huygens and it has an altitude of approximately 5,500 meters. Some of the mountains on the Moon's surface are of volcanic origin. The volcanic structure of the Moon was formed as a result of losing its internal heat due to radioactive decay. This volcanic activity caused basalt lava to rise to the surface and form large plains. The most famous plain of the Moon is the Lunar Sea, or Mare Imbrium, in Latin, a large basalt lava plain. Valleys on the Moon's surface are also notable features. These valleys are often associated with impact craters, and some are quite long and deep. Rima Cirsalis, the southern hemisphere of the Moon, is one of the longest valleys and is approximately 300 kilometers long. Another important feature of the Moon's surface is the fine layer of dust and sand called regolith. Regolith covers the Moon's surface and consists of particles resulting from meteor impacts. This layer of regolith surrounds the Moon's surface and determines its color and texture. Since the Moon's surface does not have a thin atmosphere, it is open to the void in space. Therefore, the Moon's surface is directly affected by sunlight and temperature conditions are quite extreme. The Moon's surface experiences high temperatures that can go up to about 130 degrees Celsius on the side facing the Sun, while it has low temperatures that can go as low as -180 degrees Celsius on the side away from the Sun. The formation and evolution of the Moon's surface is a major research topic for scientists. Lunar seas provide information about the Moon's geological history and volcanic activity. In addition, lunar soil and rock samples were collected from these seas during space missions to explore the Moon. These samples have provided greater understanding of the formation and evolution of the Moon. Now, let's examine the mountains on the Moon. Mountains on the Moon are elevations formed by various volcanic and collisional effects. The Moon's mountains may be similar to mountains on Earth, but differ in their formation processes and characteristics. Here are some important mountains on the Moon. Montes Alps is a mountain range located in the northwestern region of the Moon. It takes its name from the Alps mountains on Earth. Montes Alps attracts attention with its steep slopes and peaks. Montes Caucasus is a long, winding mountain range on the eastern side of the Moon. It is named after the Caucasus Mountains in the world. Montes Caucasus is often found around large diameter craters. Montes Apenninus is a large mountain range located on the southeast side of the Moon. This mountain range is located near Hadley Crater, which was visited during the Apollo 15 mission. Montes Apenninus contains several mountain peaks and deep valleys. Montes Taurus is a mountain range located on the western side of the Moon. It takes its name from the Taurus Mountains on Earth. Montes Taurus is located near several mountain peaks and craters. Mons Huygens is a solitary mountain located on the south face of the Moon. Mons Huygens is a volcanic mountain rising to approximately 5,500 meters. It is one of the highest mountains on the Moon. Mountains on the Moon provide important clues about the Moon's geological history and volcanic activity. These mountains have been studied in detail during space missions that visited the Moon, allowing us to learn more about the formation and evolution of the Moon. Craters on the Moon are pits formed as a result of meteor impacts. Craters on the Moon's surface provide important information about the Moon's geological history and the general evolution of the solar system. Large craters. There are many large craters on the Moon. These craters are pits that usually have a large diameter and depth. Some of the Moon's largest craters are Bailly Crater. It is a large crater located near the south pole of the Moon. Its diameter is approximately 303 kilometers. Clavius Crater. It is a large crater located on the southern surface of the Moon. Its diameter is approximately 225 kilometers. Copernicus Crater. It is a prominent crater on the visible surface of the Moon. Its diameter is approximately 93 kilometers. The surface of the Moon is full of many small craters. These craters are pits with diameters ranging from a few meters to several kilometers. Small craters form as a result of meteor impacts and generally have an irregular distribution. Mares of the Moon, called seas, contain craters ranging in diameter from a few hundred meters to several hundred kilometers. Mare craters generally have a flat and smooth surface. Crater chains formed as basalt lava flows to the surface can be seen in places on the Moon where basalt lava flows occur. Many small craters are arranged consecutively in these chains. The ages of craters on the Moon vary depending on the frequency of meteor impacts. While newer craters generally have more prominent and sharp edges, the appearance of craters can change over time due to erosion and other geological processes. The discovery and mapping of craters on the Moon's surface helped humans better understand the Moon. First detailed crater maps, Apollo. It was created by astronauts during their missions. During these missions, astronauts examined craters and tried to understand the origin of their sources, geological features and formation processes. Some craters on the Moon have much larger dimensions than normal craters and are called supercraters. These supercraters are notable for their large diameters and depths. For example, Super Aitken crater, one of the Moon's largest craters, has a diameter of approximately 2,500 kilometers and is located near the Moon's south pole. The study of craters on the Moon has stimulated a variety of scientific research involving such topics as the effects of meteor impacts, impact kinetics, the origin of their resources, and the geological history of the Moon. The formation and distribution of craters helps us understand the role of meteor impacts in the geological evolution of the Moon. Many of the craters on the Moon are named in honor of astronomers and scientists. For example, Copernicus crater, famous Polish astronomer Nicolaus, it is named after Copernicus. The names given to craters on the Moon reflect the importance of scientific discoveries in space exploration. Craters on the Moon differ from their counterparts on Earth and provide important information about the Moon's geological structure, formation and evolution. Future explorations and space missions will enable the discovery of more craters on the Moon's surface and deepen our understanding of the Moon's evolution. The lunar regolith is a thin layer of soil, dust, and rock that covers the Moon's surface. Regolith is formed by the accumulation of materials ejected as a result of volcanic activity and pits formed by meteor impacts. The Moon's regolith provides important information about the Moon's geological history and the general evolution of the solar system. The Moon's regolith layer is formed as a result of various geological processes. Meteor impacts shatter rocks and turn them into dust, with the transfer of energy to the Moon's surface. These meteor impacts disperse rocks on the Moon's surface, forming regolith. Enables the formation of the layer. The regolith layer is also formed as a result of the cooling and disintegration of lava erupted by volcanic activity. The Moon's regolith generally consists of materials ranging in size from fine dust to small rock fragments. Its composition is largely plagioclase. It consists of minerals such as feldspars, pyroxenes and olivine. Additionally, rare minerals on the Moon have also been detected in the regolith layer. The depth and thickness of the regolith layer varies in different regions and geological structures of the Moon. While in some areas the regolith layer is only a few meters thick, in other areas its depths can reach tens of meters. The depth varies depending on factors such as the number of impacting meteorites, volcanic activity and erosion, along with the influence of gravity. The regolith layer is firmly in place under the influence of gravity. Therefore, walking or driving on the regolith on the Moon offers a different experience compared to that on Earth. Because gravity on the Moon is about 1/6 that of Earth, less resistance is felt when walking or driving on the regolith. The regolith layer acts as an insulation layer against temperature changes on the Moon's surface. Temperature differences between the Moon's long day and night periods are very high. During the day, the Moon's surface can be quite hot, while at night it can be very cold. The regolith layer acts as a buffer against these temperature changes, mitigating temperature changes to the deeper rocks beneath the Moon. The regolith layer is an important resource for studying issues such as the geological evolution of the Moon, crater formation, volcanism, the effect of meteor impacts and the resource potential of the Moon. Apollo sent to the Moon missions and other space probes have collected samples of the regolith and brought them to Earth. These samples have provided important information about the geological history of the Moon and the evolution of the solar system. In addition, rovers sent to the lunar surface examined the regolith layer in detail and measured its physical and chemical properties. These studies provided information on topics such as the Moon's resource potential, water molecules, element distribution, radioactive properties, and provided important data for future Moon exploration and colonization studies. The regolith layer has provided an in-depth understanding of the Moon's geological structure and formation processes. Scientists plan to conduct further research with future space missions and exploration projects to better understand the Moon's regolith layer. These studies will enable us to learn more about the Moon's geological history, its resource potential, and its potential to form a strategic base for space exploration. The amount of water on the Moon was an issue for a long time when it was believed that the Moon was a dry body. However, research and discoveries made in recent years have confirmed the existence and amount of water on the Moon. Although the existence of water on the Moon was previously thought to be only isolated ice points, later studies have shown that water molecules are more widespread and spread on the Moon's surface. Water resources on the Moon are available in two main forms. The first are what are known as supercold spots, located in the cold, shadowy regions of the Moon. In these regions, away from sunlight and cold enough, water molecules can be preserved in the form of ice. The second source is known as bound water in the rocky layers of the Moon. These water molecules are trapped within the crystal structure of rocks. A number of spacecraft and missions have been used to determine the amount of water on the Moon. Chandrayaan-1, Lunar Reconnaissance Orbiter and Lunar Crater Observation Earth-Sensing Satellite, have provided important data to investigate the presence and distribution of water on the Moon. Chandrayaan-1 confirmed the presence of water molecules on the Moon by analyzing sunlight backscattered from the Moon's surface. The LCROSS mission hit a crater near the south pole of the Moon and ejected material, and then the presence of water vapor and ice was determined as a result of the analysis of this material. The LRO mission conducted more detailed studies of the water on the Moon's surface and mapped the distribution of water molecules. Although the amount of water on the Moon has not yet been precisely determined, research shows that there are millions of tons of water, called festering water, in the soil on the Moon's surface. These water molecules are found bound within the regolith layer and are widely distributed on the Moon's surface, contrary to previously thought. These water molecules are found bound within the regolith layer and are widely distributed on the Moon's surface, contrary to previously thought. Research has also revealed the presence of condensed water ice in the dark, cold craters of the Moon. In these craters, far from sunlight, water molecules can remain in the form of for future ice in supercold spots, offering a significant resource potential space missions. Determining the exact amount of water on the Moon and mapping its distribution in more detail is of great importance for future lunar exploration and colonization projects. Water resources on the Moon can also be considered as a potential fuel source by splitting water and using it as oxygen and hydrogen. In addition, the oxygen obtained as a result of the separation of water can be used to create life support systems for human existence on the Moon. We learned some information about the surface of the Moon. So what are the physical properties of the Moon? The Moon's diameter is measured to be approximately 3,474 kilometers and its radius is approximately 1,737.1 kilometers. This is about a quarter of the Earth's diameter. The surface area of the Moon is approximately 37.9 million square kilometers. The Moon is a very large satellite compared to other satellites in the solar system. For example, Mars' largest moon, Phobos, is only approximately 22 kilometers in diameter, and Jupiter's largest moon, Ganymede, is approximately 5,268 kilometers in diameter. Therefore, the Moon has a rather large size compared to other satellites. The mass of the Moon is approximately 7.35 times 10 to the 22 kilograms. This amounts to approximately 1.2% of the Earth's mass. The mass of the Moon is quite small compared to the mass of other bodies in the solar system. For example, the mass of Jupiter is approximately 1.9 x 10 to the 27 kilograms, and the mass of the Sun is approximately 1.98 x 10 to the 30 kilograms. Therefore, the Moon has a smaller mass compared to other large bodies. The chemical properties of the Moon's surface are determined by the Moon's composition and mineralogy. Most of the Moon's surface is covered with silicate minerals. These minerals include feldspars, pyroxenes, olivines and amphiboles. Silicate minerals play an important role in the formation of the dark plain and mountains on the Moon's surface. The surface of the Moon is rich in compounds containing the element oxygen. Most of the oxygen on the Moon exists in the form of oxides. In particular, compounds such as iron oxide and titanium oxide are common on the Moon's surface. The presence of hydrogen has been observed on the surface of the Moon. Most of the hydrogen exists in the form of water molecules. The existence of condensed water ice has been discovered in the dark and cold craters of the Moon. It is also thought that hydrogen can be found depending on the structure of rocks. Metallic elements are also found on the surface of the Moon. In particular, elements such as iron, aluminum, calcium, magnesium, and titanium are among the compounds commonly found on the surface of the Moon. The Moon's density is calculated by taking into account the Moon's mass and volume. The density of the Moon is approximately 3.34 grams per cc. This is approximately 60% of the density of the Earth. The density of the Earth is approximately 5.52 grams per cc. The internal structure of the Moon may cause density differences. It is likely that different densities of materials exist between the Moon's crust, mantle and core. For example, the Moon's crust is thought to be lower density. These differences may provide information about the formation and geological evolution of the Moon. The gravitational force on the Moon is a result of the Moon's gravitational field and pulls objects towards the Moon. The gravitational force varies depending on the mass and size of the Moon. The Moon's gravitational field is weaker than the Earth's because the Moon's mass and dimensions are smaller than the Earth's. Gravitational force is a force that acts on objects on the surface of the Moon. The gravitational field on the Moon is measured by the gravitational acceleration of an object. The gravitational acceleration on the Moon is approximately 1.622 meters per second squared. This value is approximately 1/6 of the gravitational acceleration on Earth. This means that the rate at which objects fall on the Moon is slower than on Earth. The gravitational force on the Moon affects the movement of objects. An object on the surface of the Moon is pulled towards the Moon due to the gravitational force. Therefore, the weight of objects is less on the Moon compared to Earth. For example, a person's weight on the Moon is approximately 1/6 of their weight on Earth. The gravitational force on the Moon also affects movements on the Moon's surface. The Moon's low gravitational field allows humans to jump higher on the Moon's surface. Additionally, the movement of vehicles on the lunar surface may be easier compared to Earth. The gravitational force also affects living conditions on the Moon's surface. The Moon's low gravitational field affects the flow of liquids and the surface tension of water is lower. Additionally, the Moon's gravitational force can also affect important factors such as the formation and maintenance of the atmosphere. The Moon's magnetic field is related to the Moon's internal structure and geophysical properties. Here is more detailed information about the magnetic field on the Moon. The Moon's magnetic field is quite weak compared to the Earth's magnetic field. The Moon does not have the ability to create a natural magnetic field. However, the Moon's magnetic field is influenced by the Earth's magnetic field. The Moon's magnetic field is formed by the influence of the part of the Earth's magnetic field that reaches the Moon. The Earth's magnetic field is formed as a result of the interaction of charged particles carried by the solar wind reaching the Moon's surface. When these particles hit the Moon's surface, they create a magnetic effect, which creates the Moon's magnetic field. The Moon's magnetic field differs from that of the Earth. While the Earth's magnetic field behaves like a magnetic dipole, the Moon's magnetic field has a more complex structure. The Moon's magnetic field can be affected by the magnetic properties of minerals and rocks in the Moon's internal structure. The Moon's magnetic field has been measured by lunar missions and space probes. Magnetometers placed on the Moon during the Apollo missions were used to measure the Moon's magnetic field. The data obtained showed that the Moon's magnetic field is quite weak and is affected by the Earth's magnetic field. The Moon's magnetic field provides information about the Moon's geological evolution and internal structure. Magnetic field data can provide clues about the magnetic properties of the minerals and rocks the Moon contains. These data provide a better understanding of the Moon's formation and geological processes. The Moon is a celestial body without an atmosphere. Therefore, instead of talking about the Moon's atmosphere, we can talk about the thin layers of gas and dust on the Moon's surface. There is a thin layer of gas with very low density on the surface of the Moon. This layer consists of gases and particles dragged by the solar wind hitting the Moon's surface. However, this layer of gas cannot be considered a conventional atmosphere because its density is too low and it does not have atmospheric functions. The gaseous layer on the Moon's surface generally contains noble gases. These are elements that bounce off the Moon's surface and turn into gases under the influence of the solar wind. These noble gases include helium, neon, argon and others. However, these gases have very low density and are not dense enough to form the Moon's atmospheric properties. There are also fine layers of dust and particles on the surface of the Moon. This dust and particles originate from collisions on the Moon's surface and remain on the surface due to the influence of gravity. Dust and particles cover the Moon's surface, giving it a characteristic gray color. Although these are too dense to be considered the Moon's atmosphere, they influence optical properties on the surface and affect the Moon's appearance. The formation of the Moon is based on a theory called the major impact theory, which is generally accepted among scientists. According to the large impact theory, the Moon was formed as a result of a Mars-sized planet colliding with the young Earth in the early solar system, approximately 4.5 billion years ago. This collision occurred when the planet called Theia crashed into the Earth. As a result of the collision, a large part of Theia broke apart, and these pieces gradually coalesced to form the Moon. The materials of Theia and Earth mixed, making the Moon's contents very similar to Earth. This collision initiated the formation of the Moon, which orbited the Earth and became its satellite. During the formation of the Moon, some of the energy and heat released as a result of the collision melted the Moon. The lava formed as a result of the melting spread over the surface of the Moon and started the volcanic activity process of the young Moon. These lavas formed the basaltic layers that cover the Moon's surface. With the formation of the Moon, the period of intense bombardment of the early solar system began. Asteroids and comets constantly crashed into the Moon's surface. Craters and pits formed as a result of these collisions became one of the characteristic features of the Moon's surface. With its formation, the Moon was captured by the Earth's gravitational force and began to revolve around it. This rotation caused the Earth-facing side of the Moon to always face the same direction, a phenomenon known as lunar rotation synchrony. It provides valuable information about the formation of the Moon, the evolution of the solar system and the process of planet formation. By examining the geological features of the Moon, scientists shed light on the early periods of the solar system and the formation process of the Earth. The orbit of the Moon is a circular orbit determined by the gravitational force of the Earth. The Moon rotates around the Earth and acts as a satellite. The Moon's orbit is determined under the influence of the Earth's gravitational force. The Earth has a large mass and therefore a strong gravitational force. This gravitational force pulls the Moon towards itself and causes it to rotate around it. The Moon revolves around the Earth in an elliptical orbit. This elliptical orbit causes changes in the Moon's distance and speed from Earth. The Moon moves between 2 points called perigee and apogee. Perigee is the Moon's closest point to Earth, while apogee is the Moon's farthest point from Earth. Since the Moon's orbit is controlled by the Earth's gravity, the Moon is like a falling object under the influence of the Earth's gravity. Therefore, the moon experiences an acceleration towards the Earth. However, the speed of the moon in its orbit and its gravitational effect create a balance point, preventing the moon from constantly falling to the Earth and maintaining its orbit. The moon's orbit is completed in a period lasting approximately 27.3 days. This time allows the moon to make one complete orbit around the Earth. The moon experiences changes in its speed depending on its distance from the Earth. It moves faster at the perigee point, where it is closer, and slower at the apogee point, where it is farther away. The moon's orbit may also undergo changes under the influence of the gravitational forces of other planets and the sun. These effects cause the moon's orbit to change slightly over time. This phenomenon can be seen at points called the moon's nodes, where the moon's orbital inclination and orbital plane changes are observed. Now let's examine what tide is. Tides are the regular and recurring rise and fall of sea level. Tides are created by the force of gravity and the gravitational interactions of the moon and the sun. These gravitational interactions affect the Earth's fluids, creating tides in the seas and some lakes. The influence of the moon is the most obvious factor in the formation of tides. The gravitational force of the moon creates a gravitational effect on the Earth. As the moon rotates around the Earth's gravitational force pulls the moon towards itself, and the moon's gravitational force also affects the Earth's water mass. As the moon's gravitational pull pulls on the mass of water near the Earth, this body of water moves towards the Earth, causing sea level to rise. This point is called the high tide stage, and high tides occur. At the same time, there is a point on the other side of the Earth where the gravitational force of the moon is felt less. At this point, the sea level drops and low tides occur. Tides interact with the rotational motion of the moon and the rotational motion of the Earth. The tilt of the Earth's axis of rotation affects tidal events and causes tides of different sizes and periods. The sun also contributes to tides, but the moon's influence is much more pronounced because the moon is closer to the Earth than the sun. Tides have significant impacts on many areas such as marine life, coastal erosion, ship navigation and maritime activities. In some areas, high tides and low tides create large differences in sea level and can affect maritime activities. Now let's examine the lunar eclipse. A lunar eclipse occurs when the Sun, Earth and Moon align in one direction. Since the Moon orbits close to the Earth, it is possible for the Moon to enter the Earth's shadow. However, a lunar eclipse does not occur on every new moon or full moon. Because the Moon's orbit is slightly tilted from the Earth's orbit, the Moon often passes over or under the Earth's shadow. A lunar eclipse covers rare occasions when the Moon passes through the Earth's shadow. Lunar eclipses can be of two basic types: total lunar eclipse and partial lunar eclipse. A total lunar eclipse refers to a situation where the Moon is completely covered by the Earth's shadow. In this case, sunlight is refracted through the Earth's atmosphere, and the Earth's atmosphere reflects a reddish color to the Moon. Therefore, during a total lunar eclipse, the Moon is usually seen in a red color. A partial lunar eclipse refers to a situation in which the Moon is covered by only part of the Earth's shadow. In this case, part of the Moon remains in darkness while the other part still remains in light. Partial lunar eclipses occur when the Moon passes through only part of the Earth's shadow. Lunar eclipses are usually observed at night. Since the Moon is positioned directly opposite the Sun, a lunar eclipse usually occurs during a full moon. Lunar eclipses can be viewed around the world, but it is important that the observation location is close to midnight. The lunar eclipse event provides an exciting observation opportunity for astronomy enthusiasts. People can observe through telescopes or with the naked eye to watch this phenomenon. The lunar eclipse is also an important source for scientific research. Spacecraft examining the Moon's surface can collect data on the Moon's atmosphere and surface during a lunar eclipse. The lunar eclipse event has great historical and cultural importance. In many cultures, lunar eclipses have been the subject of mythological and religious narratives. Lunar eclipses have helped people in the past improve their ability to understand and follow natural events. Scientific explanation of the lunar eclipse event allows us to understand the movements of the planets, satellites and the Sun. Lunar eclipses help us understand the basic principles of astronomy and expand our knowledge of how the universe works. At the same time, thanks to lunar eclipses, we can better understand the gravitational interactions of the Sun, Earth and Moon and the dynamics within the solar system. Observations about the Moon have been recorded by humans throughout history. Tracking and observing the movements of the Moon has been going on since the early times when people tried to understand natural events. In ancient times, the Moon was a subject of great curiosity and admiration for people. Observing and trying to understand the movements of the Moon arose from people's need to follow natural events and organize their calendars. The Egyptians carefully followed the movements of the Moon. For them, the Moon was a symbol of fertility and time. By observing the phases of the Moon, they planned their agricultural activities and used the movements of the Moon to predict the floods of the Nile River. The Babylonian civilization systematically recorded the movements of the Moon and created their lunar calendar. Babylonian astronomers tried to predict future events by carefully observing the phases and eclipses of the Moon. They also tried to determine the positions of other planets using the movements of the Moon. The ancient Greeks also observed the movements of the Moon and studied them mathematically. They developed geometric models to predict the Moon's rotation rate and orbit. The movements of the Moon have been a subject of great interest in the fields of astronomy and mathematics. Observations on the movements and phases of the Moon were also made during the Roman Empire. The Roman calendar system was based on the phases of the Moon and was organized into lunar months. During Roman times, tracking the movements of the Moon was important for timing agricultural activities and planning religious festivals. During the Middle Ages, lunar observations played an important role in scientific studies and interest in astronomy, especially in Europe. Scientists in the Islamic world also studied the movements of the Moon and made important contributions to the field of astronomy. In the Middle Ages, scientists in the Islamic world carefully observed the movements and phases of the Moon. Islamic astronomers attempted to predict the Moon's orbit and phases using observation and mathematical calculations. Especially Ibn al-Haytham and Nasiruddin scientists like Tusi have carried out important studies on the movements and eclipses of the Moon. Although scientific studies were limited in Europe during the Middle Ages under the influence of the Church, observations of the Moon were still carried out by many scientists and astronomers. Especially monks living in monasteries observed the movements of the Moon and kept records. These observations were used in the creation of lunar calendars and calendrical calculations. In the Middle Ages, observations of the Moon were generally based on observation and mathematical calculations. Tracking the movements of the Moon was important for keeping track of time, organizing calendars, and making astrological calculations. Observations on the phases and movements of the Moon contributed to scientific studies and the development of astronomy knowledge. However, in the Middle Ages, there were some limitations to scientific progress and observation. The influence of the Church and dogmatic thoughts limited observation and astronomy studies. In the New Age, lunar observations gained significant momentum with the development of technology and the increase in scientific research. Lunar observations carried out in the New Age have become more comprehensive with both telescopic observations and manned moon journeys. The invention of the telescope in the 17th century took lunar observations to a new dimension. Galileo Galilei observed the surface of the Moon in detail using a telescope in 1609. Galileo's observations enabled him to explore the mountains, craters, and seas of the Moon. Later, other astronomers and amateur astronomers also examined the Moon using telescopes and obtained new information. The Apollo program, carried out in the 1960s, took lunar observations to a completely new level with manned missions to the Moon. Apollo astronauts landed on the Moon, examined the Moon's surface closely, collected samples and obtained scientific data. During these missions, more comprehensive information about the Moon's geology, craters, rocks and other physical features was obtained. In the New Age, space telescopes and orbiters also played an important role for lunar observations. Telescopes such as the Hubble Space Telescope have been used to study the Moon's surface and features in greater detail. Additionally, spacecraft orbiting the Moon have been used to measure and study the Moon's magnetic field, gravity, and other physical properties. Today, amateur astronomers and professional astronomers still continue their observations of the Moon. The Moon's surface, craters, mountains and other details are observed using telescopes, cameras and other observation tools. Additionally, space agencies and astronomy communities conduct studies on lunar observations and exploration and carry out projects to obtain new information. For example, NASA's Artemis program aims for a manned return to the Moon and aims to observe the Moon in more detail. These observations will provide more information on topics such as the Moon's geology, volcanism, resources, and potential traces of life. Lunar observations are made not only for scientific discoveries, but also for education, cultural heritage and public interest. Events such as lunar eclipses are important astronomical events that are followed and observed by the masses. Amateur astronomers and astronomy enthusiasts organize various events to track, photograph and observe the Moon. Don't forget to subscribe for brand new documentaries and more scientific content.